can measure in front view. The length of front view L in this front view, that is L. So we know radius in this case. This is an arc, so this is a radius. Is we know this is radius, this is arc length, and relation we know about radius and arc length. This is the relation radius r. See, if this is an arc, this is arc AB, right, and this angle is theta and radius is r, then what is the length of AB? AB is equal to radius into angle, r into theta, right. So radius multiplied by angle theta gives us the length of arc. But in our case, in this case, we don't know theta. We know radius r as well as AB. So how to find out theta? Theta is equal to AB upon r. So in our case, what is AB? AB is the length of arc upon r, means the length of slant edge, right. So length of this arc is equal to pi into d, right, or it is equal to 2 pi into r. R is the radius of the cone upon length of the slant edge. So angle theta is equal to 2 pi, means 360 degree if we convert into degree. R is the radius of the base circle upon length upon L. L is the length of the slant edge. So this is the equation which is to be used to develop the surface of this cone. So in our case, over here, this is point A to B, this is arc, right, and AB is equal to, in our case, AB is equal to 2 pi r, 2 pi into r, that is AB, this length, right. Now what's about this angle theta? This angle is theta. So this theta is equal to, as per our derivation, theta is equal to 360 degree into radius upon length of the slant edge. So here this is the length of the slant edge, this total, or in our cone, this is a cone, right. So this is L, right, this is L, radius is r. So equation becomes this one. This is the equation, theta is equal to 360 degree into radius upon L. Now we will use this equation to solve any problem of the cone, of the development of cone. Now we will back to our original problem. See, in this case, here we have developed the cone sector of a circle like this. L, r is the base circle radius, L is the slant height. So angle theta is equal to r upon L into 360 degree. This equation we have derived here, that is r is the radius of the circle and L is the length of the slant edge. This is angle theta, and this is the development of the lateral surface of the cone. Now what's about lateral surface of tetrahedron? Tetrahedron means what? You know, the tetrahedron means 4 equilateral triangles are coupled together, are joined together like this. This is an tetrahedron, and development of tetrahedron means all the sides of equal length in case of tetrahedron. And what would be the development? 4 triangles are there, 1, 2, 3 and 4. 4 triangles are there, and this makes an tetrahedron solid. So in reverse also we can think of that. If we take an equilateral triangle, divide this equilateral triangle into 4 equal parts like this, which is shown over here, tilt it like this, fold it over here and complete it and fold them, so and we can make an tetrahedron like this. So that is development of another solid, that is tetrahedron. Now development of lateral surface of cube. Cube means all sides are of equal length, that we know. So in case of cube, all sides are there, say there are 6 faces are there, 6 squares are there, all squares are like this, and development would be the 4 squares, that is lateral surface, upper surface and lower surface. So this is complete development of cube, right? 4 squares, one is upper one, that is top face and bottom face. So that is development of a cube. Now about frustum. Frustum is very important as far as the industrial need is concerned. The development of frustum of cone is like this. Frustum means if any cone is cut at its high, at certain height, which and the cutting plane is parallel to its base, in that case it would appear as a frustum like this. This is a frustum. And how to draw the development of frustum? We use similar analogy which is used in case of cone. Take L1 L is the height, L is the length of the slant edge. Draw an arc, find out angle theta which is covered. Angle theta is equal to R upon L into 360 degree. The equation which we derived earlier, put it over here. R is the radius of the cone or cone base. L is the length of the slant edge. Put those two values in this equation and find out angle theta in terms of degree. And put that angle over here, that is theta. R is the base circle radius of the cone and L is the slant height of the cone and L1 is the slant height of the cut part. Now to draw development of this surface, draw an arc in this given length. The arc length AB, that would be equal to periphery of the base of this cone. After drawing this arc, draw another arc for the bottom surface or smaller surface or slant height of the cut part L1, and this is the development of given frustum. Now another, darken this developed portion and lighten the remaining parts. Now another frustum, development of frustum of a square pyramid. This is a square pyramid, means pyramid is cut in such a way that the cutting plane remains parallel to the base like this. Similarly, it's a pyramid, so 4 triangular faces would be there. L is the slant height of the pyramid, L1 is the slant edge of the cut part. Draw an line, length is equal to L. Draw an arc of any length, cut arcs at a distance of L or at a distance of side length of this square base. 4 triangles would be there. This is the base side, 1, 2, 3 and 4. 4 sides would be there. Join them with a straight line to an apex point, and this is the triangle. So 4 triangles are there in case of square pyramid. But here this square pyramid is a frustum. It is cut from the upper face. So again, what we did earlier in earlier case, similar exercise do over here. Take L1 as the length, put it over here, cut, draw an arc and draw 4 top side over here, 1, 2, 3 and 4. Now darken this required portion and lighten this bottom portion. This is our answer. These 4 developed triangles which is cut from the top side. So this is development of a frustum of a square pyramid. Now prism. This is an example of one prism. A pentagonal. Now to solve any kind of problem, just keep something in mind. First decide which kind of solid is given to you. Here pentagonal prism is given to us. Now in case of developments, always you have to think that it is lying on HP, right? In that case it would be easier to imagine the given conditions, because in this case majority of the problems are given with this condition. So we assume that the pentagonal prism is lying on HP on its pentagonal base. So here side length is given 30 mm and 50 mm is the height which is given over here, and it is resting on its base whose one side is perpendicular to VP. So we have to draw pentagon in such a way that the one side becomes perpendicular to XY line. Now it is cut by a section plane 45 degree inclined to HP through midpoint of the axis. Again here midpoint of the axis come into picture. Draw development of the surface of remaining solid. So first we draw the first XY line that represents intersection of horizontal plane and vertical plane. Draw XY line and draw a pentagon such that one side becomes perpendicular to XY line. Here I have drawn pentagon in such a way that this side, this is one side, this side is perpendicular to XY line. Here it is given in the problem that its base whose one side is perpendicular to VP. So this is top view of this pentagon. Now its front view would be, first locate all these points, find out its axis and draw its front view, taking height is equal to 50 mm, and at a height of 50 mm draw a rectangle. 5 sides are there. Here side B and E are co-in line over here, and this is the axis of this prism. Now after drawing front view and top view, our duty is to find out the midpoint of this axis, because it is cut by a section plane which makes an angle of 45 degree with horizontal plane through the midpoint of the axis. So first we need to find out the midpoint of the axis, and so the midpoint of this axis would be at a distance of 25 mm from the base. So from the base at a distance of 25 mm, find out one point which is over here. This point is at a distance of 25 mm from the base. Now from this point draw a line at an angle of 45 degree with XY line and mark the points. Here one point is there. See, here only A edge is there, so one point would be here. Here 2 points are there, intersection of this vertical line and this section line. 2 points are here and 2 points are here. Name these points as A dash, B dash, C dash, D dash and E dash. You can name 1 dash, 2 dash, etc. also. After naming these points, take draw generators or projection lines from all these points. Projection line means line drawn from these points. Draw very light lines from all these points, that is A dash, B dash, C dash, D dash, E dash. Now the development of this prism would be a rectangle. It's a pentagonal prism, so 5 rectangles would be there. As we know, we can name them A, B, C, D, E and again back to A. So first we have drawn the development of this prism, which is not cut, uncut prism. We assume that the prism is not cut and its development would be like this. Now if we cut this prism at certain angle, what would it appear? How would it appear? Say this A. On point A, these are the points. From point A dash is over here on generator A or on side A. So from this point draw horizontal line which cuts A at this point. From B, draw horizontal line which cuts B at over here. Similarly C over here, D over here, E and back to A. So these are the points on the developed surface. Join all these points with a straight line, as it's a prism of straight lines. After joining this, make it darken and lighten this upper and lower portion which is not needed. So this is the final development of our given solid. You can draw these lines as well. So this is the development of the prism. Now another problem of cylinder. Now think about the given data. Here data is given that a cylinder of diameter 50 mm and height 70 mm is standing on HP on its circular base. Now and it is cut by a cutting plane which makes an angle of 45 degree with horizontal plane, and it passes through the midpoint of the axis. Draw development of surface of the remaining solid. So first think about first line. What would be its top view and front view? So for that, first of all draw XY line and draw a circle of given dimension, that is 50 mm. Diameter is given as 50 mm of the circle. Draw projection lines and complete and make a rectangle of 70 mm height. This is given data, right? After inserting its dimension, center line, see here you should take care about this. Many students skip to locate various types of lines. Here this middle one, this should be drawn a center line. Here dimensions should be inserted by any single dimensioning method. Suppose I have inserted here dimension with align method, then throughout this drawing you should go through the similar dimensioning method. Say here 70 mm with a similar method. You cannot use unidirectional method over here and align method over here. And as far as possible, all the dimensions should be inserted once in the diagram. It should not be repeated as well. Here diameter 50 mm and 70 mm height is given. Horizontal line, find out midpoint of the cylinder which is at a height of 35 mm from the base. Now from this point draw a line or cutting line which makes an angle of 45 degree with XY line. So this we have cut this cylinder, right? So this is given. Now how to draw development of this cylinder? As we know, the development of cylinder is just a rectangle which is having height is equal to height of this cylinder as well as width is equal to, what would be width of the development? That would be equal to periphery of the circle. Now how to draw those? So for that we draw imaginary lines over the circular face of the cylinder, that is A, B, C, D, E, F, G, H. Name all these points, divide into 8 equal parts. We can divide into any number of equal parts, but thing is that they should be equal in nature. You can divide into 12 equal parts or 16 equal parts. Here we have taken 8 equal division of this cylinder and draw vertical lines from all these points, and these lines cut at certain points to the cutting plane, that A dash, B dash, C dash, D dash, E dash, F dash, G dash and H dash. So this is just the problem, given problem that we have assigned. Now what's about development? To draw the development, as we know, first of all, draw a rectangle of given height and width. Height is equal to 70 mm and width is equal to, yes, length is equal to periphery of the cylinder base, that is equal to pi into d. Length is equal to, pi means 3.14 into diameter is 50 mm. So total width of this rectangle would be 157 millimeter. This is 157 millimeter. Now divide this rectangle into n number of parts. So here circle is divided into 8 parts. So divide this width is equal into 8 equal parts. Say 2, 2. So 4 equal division and make 2 division of all the parts. So 8 equal divisions of this given width. If we have divided the circle into 6 parts or into 12 parts, an according number of divisions should be made over here. Here we have divided into 8 equal parts. Name these points A, B, C, D, E, F, G, H and back to A. These are the names. So we start from here, A, B, C, D, E, F. These are A, B, C, D, E, F and so on. After naming these points, take appropriate points from A dash, draw a horizontal line like this, right, which cuts vertical line from point A at point A dash. From point B dash, this is B dash, draw horizontal line like this, which cuts over here at some point, that is B dash. Similarly, this is B dash, then this is C dash, then this is D dash, vertical horizontal line from point D dash, which cuts over here, that is at point D dash. Similarly, E dash point is there, then F dash, then G dash, then H dash, and then back to A dash. So these are the endpoints of this developed solid. If the solid is cut at certain angle, at the given angle, and if you develop, these are the points. Now join all these points with a smooth curve, as it is it's a circular in shape, so we should join all these points with a smooth curve. You should take care about one thing. If the solid is